Hey there, students. Welcome to Van Cleve's Classroom Quarantine Edition, I guess. We are just starting Unit 9, Stoichiometry, and that means we're finally getting into something that I have been waiting all year to tell you about. There's a number that's going to be coming up a lot. We'll talk a little bit more about how to do problems with them in a later video, but my goal for this one is just to try and wrap our heads around what is Avogadro's number. It's a really big number, and we refer to it as 1 mole. I went ahead and wrote it out. 1 mole is equal to 6.02 times 10 to the 23rd, or if you want to count it out the long way, that is a 602 sextillion. That is a big number. That is a trillion, 602 trillion times 1 trillion. So let's just try and conceptualize how big this is. Now, it's like any other kind of number. It's like how a dozen is 12, or a yard is equal to 3 feet. A mole is just a really, really big number that we use in chemistry. If you were to, say, have 1 mole of grains of sand, you would probably have about the amount of sand on all the beaches on the planet. If you had a mole of marshmallows, that would cover the United States to a depth of 650 miles. That's much larger than the height of where our atmosphere effectively ends. If you had 1 mole of rice grains, this is one of my favorites. If you had a mole of rice grains, tiny little grains of rice, that could cover all the land area on the whole planet to a depth of 75 meters. This is more grain than has been grown in the history of time. Since people first started agriculture thousands of years ago, they have not managed to grow, and I'm not just talking rice, all the grains, all the wheat, all the barley, all the oats, everything that has ever been grown and harvested in agriculture, that we still haven't gotten to that number in all of human history. 1 mole of marshmallows, I already said that. And if you had a mole of basketballs, it would fit into a basketball bag that was roughly the size of the Earth. 602 sextillion is a huge number. Oh, there's another fun one. If you had a mole of marbles spread over the Earth, that would cover it to a depth of about 80 kilometers. And if you had a mole of peas, green peas, kind you eat for dinner, that would cover the Earth and 250 more planets the same size as the Earth to a depth of about 1 meter, 1 yard-ish. Although probably one of my favorites is what would happen if you had a mole of pennies and you were to stack them on top of each other. If you had a mole of pennies, how tall would that stack be? Well, it would make it easily to the moon, and you could keep on going. It would be the distance from the Earth to the Sun, and you could continue that because it would keep on going out past Pluto to the nearest star, Proxima Centauri. Actually, I think that's the second nearest star. And back. That's about 4 light years-ish, 4 point something. Your stack of mole of pennies could go from here to Proxima Centauri and back 7,448 times. This is a huge number. Now, at this point in my lesson, I'd like to ask students to just visualize, think to yourself, what would happen if we were in our classroom and I had a mole of water? Since I don't have anybody to raise hands and ask questions or make suggestions, I usually get a lot of people who are saying, oh man, with a mole of water, not only would we be swimming and drowning and inundated, it might cover the entire school, it might wash away the whole town. But I actually have a mole of water right here. Measured it out before I did this. In this baby bottle, which is the thing I had that had milliliter markings on the side. 1 mole of water is a little less than 20 milliliters. It's about 18 grams of water. How is this a mole? If that number is so big, after all those things you just said, Van Cleve, how is this a mole? It has about 602 sextillion water molecules in it. you know, give or take a couple of quadrillion, because when you're dealing with a number this big, a quadrillion is a rounding error. A mole is a really big number. In my next video, we'll talk a bit more about how to solve problems with moles, but the reason why it's a useful number is not because the mole is huge, but because molecules are so tiny that you can measure out a mole of them, or 2 or 10, in the lab. And that's what we're going to talk more about when we get into stoichiometry. I'm really excited. I hope this works out. Let me know how you feel about having videos like this. Yes, no, maybe so. And we'll be in touch.